Hello everyone. Today in this video tutorial I am going to take a look over a new sensor that is ADS1100. Now to get a better view regarding this sensor, what we have to do is to log in to the website that is controleverything.com, and here we have to search on for this sensor and let's see what we got here. It's ADS1100 and here you can see it's a 16-bit one channel analog to digital converter, and also you can have some view over some of the features which are clearly visible on this very screen. And the plus point is there you can purchase this sensor from this website from here. Furthermore, I will be interfacing the sensor ADS1100 with a particle photon, and I will be requiring a particle code to connect that. And for that, let's go to the source tab, and here comes the code sample. As you can see, now you can download the code sample as zip file from here. Also, you can have the code from github.com, and the repository there is Control Everything Community, from where you can have the code. Now, what do we require next is to connect some hardware, some setup, and let's see how to get there. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. The next thing we require is our sensor, that is ADS1100. Now this here is a connecting cable. Now this connecting cable is very useful in making connection with the sensor and the I2C shield, and making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the I2C shield, just like that. As we are done with all the connection setup, what do we require next is to have a look over the code. Now let's have a look over the code, and for the interfacing section we need to log into github.com, the website, and after that we have to search for the repository that is Control Everything Community, and then after that we have to have a search that is the sensor ADS1100, and let's see what we got here. And this here is a particle code, but before that let's have a look over the instructions we need to fulfill. And it says that we have to log into a particle photon and set up the device according to the steps, and the steps are provided on this very link. And let's have a look over this link. As you can see, these are some of the instructions we need to follow to set up our device for the particle photon. And after that we have to download or git pull the code, and on the online ID we have to copy this entire code, and this is the link build.particle, where we have to create a new file and then save it. As you can see, this is opening up, and here we can save the entire code just like that. And at the very end, but not the last, we had to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs, which is on the dashboard. And dashboard.particle.io user logs is the platform where you can have the result output onto the screen. Now get back to the particle code so that I can explain it line wise line. As you can see, it's a .in extension file, and in the code you notice that we have included some of the libraries, which include application.h and spark wiring I2C.h, and we have defined the address of the sensor, that is 0x48, and we have initialized a raw ADC 0.0. Now in the void setter function we have some variable set, as you can see, and we have initialized I2C communication as master along with serial communication with the baud rate equal to 9600. Then we have to start the I2C transmission, where we are going to write some data in the form of commands we are going to send, and it's continuous conversion mode 8 SPS, and it will be 0x8C. After that we have a void loop function, as you can see, and we have unsigned int data of 2 array. As you can see, we have requested and read 2 bytes of data, which you can see raw ADC, MSB and LSB. After that we have the conversion of the data takes place here, which we have followed the rules described clearly in the data sheet for ADS1100. At the very end of our code, we have the output to be displayed onto the dashboard, which is exactly the digital value of analog input and its a raw output value. Now, what do we require next is to have a look over the working. So let's have it. Well, coming to the practicality of this code, the first step is to copy this entire code of the particle, and then we have to open up the build terminal as to create a new file. We have just copied and then we have to paste it, and this is the name of the sensor. We will name it ADS1100, and then we have to verify the code. After that, the code is verified, we have to flash the code, and while flashing the code, we have to check for the magenta flash. As you can see, we have a successful notification of the flash, and you can also see onto the screen. Now we have to open up the dashboard link, and we can have our output data onto the screen, which is the user logs. As you can see, it's opening up, and we can have our values onto the screen. So we have the values. As you can see, we have the digital value of analog input. It's almost constant and near to zero because there is nothing connected. But when I instead provide a AA battery of 1.5 volt and connect it to the terminals, you can see the values there onto the screen. It's almost constant because the battery is connected to there, and we can have our values onto the screen. It's almost constant. As you can see, we have the digital value of analog input. So this is how the sensor responds. Now the next step is to look over the applications benefits of this sensor. The ADS1100 is a precision, continuously self-calibrating analog to digital converter with differential inputs and up to 16-bit of resolution. The ADS1100 uses an I2C compatible serial interface and operates from a single power supply ranging from 2.7 volt to 5.5 volt. ADS1100 is designed for applications like portable instrumentation, industrial process control, smart transmitters, factory automation, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.